Greetings, Algebra 1. This video is for Algebra 1, section 8.2. You should have in your packet a page of notes that's titled 8.2 at the top, reminding you we're talking about a thing called rational expressions, which means there's fractions that have polynomials in them. Polynomials are all of these adding and subtracting monomials, items. These are monomials with one item. Here's a binomial with two. Trinomials over there with three. What we're looking to do is what the notes say we're supposed to do. We're trying to, first, if there's adding or subtracting, like yesterday, you have to factor. And after you factor, we're looking to cancel things. And then, as always with multiplying fractions, you're going to go straight across. So we start off with a real easy one from like 7th grade-ish days. There's no adding or subtracting here. We could try to cancel. Canceling is hopeless. So what you then do is just go straight across. But the three-step plan would be for a bigger problem, factor, then you can cancel, then you can go straight across. Straight across here would just be 6 on top of 35. There's still no factor because there's no adding or subtracting, but we can cancel. 3 goes into 9 3 times. 4 goes into 8 2 times. And that's the simplest way to get to 2/3. It's not wrong to multiply straight across and get 24 over 36, but you made your life harder because now you're going to have to reduce a bigger thing. This, for the third time, there is no factoring necessary because there's no adding or subtracting. We're just looking for available cancels, and I see none. So then we're looking to just multiply straight across. We get a 35 from the numbers, you get an X, you get an A. On the bottom, there'd be a 54. You get a Y, you get a B. That's all you could really do. Going to this one, we still continue to be unnecessary to factor, no adding or subtracting. We're just going to go straight across or potentially cancel sometimes. Sometimes people are tempted to cancel a pair of X's like this, and that's not a good idea. You only want to cancel any top with any bottom. If you get matching things on the bottom, multiply to get x squared. X times x is x squared. Y just sits there. 3 times 4 is 12. If you have the hang of this, try this one out with a paused video, see if you do it yourself. I'm looking to definitely cancel on this one. 9 into this is a 2. 5 into that is a 2. You can recancel the numbers you created. The 2 can recancel the 2, and those are gone. In X world, this is supposed to be a 2, a little messy, sorry, but 2 cancel with one of those X's to leave an X on the top where there were originally more. Y3 knocks off the other Y3, and we have a stray Y from this. If the whole bottom disappears, I don't need a bottom, grab an eraser, don't need a fraction, just go with XY. Finally, on this, we have to think about factoring. You can't cancel if there's things involved in adding and subtracting. You might remember from earlier discussions, anytime there's adding or subtracting on the top or the bottom, there are invisible parentheses that are here. So that might help some of you. You don't have to put those on, but it certainly doesn't hurt. On the bottom, you can factor. The rest of this will be sort of a factoring seminar. You always look first for a GCF. 5 is in common to both of these numbers. So divide off of 5. This is out. X is in, plus is still there, and 5 divided by 5 is 1. Over here, likewise, we're looking for a GCF. 2 is on both numbers. Divide by 2, so we have an X, a plus, a 1, and that's out. 3 goes into both of these, so we have an X, a minus, and a 2, and that's out. Ignore the originals, just focus on the ones that are in, and look for matches. X minus 2's can cancel. X plus 1's can cancel. That's all we have. Top has left standing a 2. And the bottom has 5 times 3 is 15. And we're just going to continue that throughout. If you think you got the hang of that, go ahead and just hit pause. Do these problems that are on your notes paper. We're looking to factor. We're looking to cancel. And then you write down what's left. If you need me, here I am. So factor off of 5 to get x plus 3. Factor off of 10 to get x plus 4. Factor off a 21 to get x plus 1. Do a 7 to get x plus 3. And then we look for matches. X plus 3's. That's it. That's all we've got. It's numbers. 7 can do the 21. Leave a 3. Some people misunderstand that they canceling is only for diagonal numbers. It's any top with any bottom anywhere. If you were here for 7th grade, you might even remember a problem I did that basically filled the whole way across the entire board. And we cancel and cancel and cancel. And we started off with like 20 fractions. And then the answer ended up being like 2/3 or something. Any top with any bottom anywhere. So 5 and 10 can cancel. One top, one bottom. That gets us a 2. So surviving items on top, there's a 3. There's an x plus 1. On the bottom, there's a 2. There's an x plus 4. And we're good. If you wanted to distribute that out, you could, but there's no advantage to that. This can't really factor. If you're just looking without powers at an x, there's no powers there, no factoring there. Just, if you like the invisible parentheses, put them. Here we're going x squared makes x and x, like we just did all factor review week and all chapter 7. With the plus, we go same signs as that. Adding to make 6 has to be 5 and 1. So that's been replaced. This, x and x, again a plus, so we get the same as that, minus 1 and 1, so that's been replaced. You could write that as a square, but there's no real advantage to writing it as a square yet. This is a difference of squares, so xx, different signs, pair of 1s, that's out, and then cancel mania, x minus 1s, x plus 1s, more x minus 1s. The whole top vanished, so leave a 1. And the bottom has an x minus 5 with or without the parentheses. That's up to what your own style is on that. This one, I'm going invisible parentheses made visible to help people that like them. This would go x plus 2, x plus 1. This would go x plus 2, x minus 2. If the factoring, I'm going too fast for you, you might want to rewind to the factoring, not this video, but go look back to the old factoring video from a week ago, and that gives a more detailed seminar on these factoring moves. X plus 2s, x plus 1s. So we have x plus 3 on top, x minus 2 on the bottom. This one, the 2, can we do a GCF like the problems we did about 6 problems ago to go x plus 3. 4 likewise, x plus 5. This is a difference of squares. Starts with 3's, put a plus x and a minus x. This we go x's, different signs from the minus. Subtract to get 2 would have to be 5 and 3. Plus takes the bigger number because that sign does that job. 5 and 3, zip. X plus 3 is a perfect cancel with 3 plus x. Adding can add in any order you want to add. No harm if we switch the order of those. 3 minus x and x minus 3, you might remember from yesterday's video, if you subtract backwards, that is a small issue. You can still cancel the subtract backwards, but you have to leave a negative sign to pay for that difference. X plus 5s can go. 2 can cancel with 4 to leave a 2. I really should have crossed this off about 60 seconds ago when I did the factoring. I should have eliminated that probably to avoid confusing anybody. But I have a negative in the beginning that I threw in for that backward subtracting. There's a 2 on the bottom, and there's only a 1 left on the top because we removed everything else. Last one, this has a GCF, so 2, x plus 5. This does not have a GCF because 1 doesn't help us, so I'm going to go invisible parentheses. This has a GCF, 2 can come off for x squared plus 8x plus 15. And that can go again. That can go x and x, pluses, 5 and 3. This you can't take out of GCF because 7 and 3 don't cooperate. So we have to do a little bit of a guess check move. And here's something I'll usually do to kind of cheat on this in a way. We have a context here for this problem that can help us not probably have to guess. The authors of this book have created the problems probably to cancel. And so high likelihood that this is going to cancel in a minute. So when I make my guess, I'm going to guess that it's probably that one to help me make the 2. And to make a 3, I'm guessing it's probably that one. So I'm not going to blind guess like I used to. I'm going to look around and just see if they might have helped me out. Check it still, like always, but there's a 1x, there's a 6x. Together does make 7x, and that almost always happens. Save the hardest factor for last, and just look around for like, see if you can put the pieces together. I think it'll help speed you up. And then cancel x plus 5s, and x plus 3s, 2s, 2x plus 1s. Cancel mania. If you get rid of everything, answer is 1. In any of these individual spots, I could have been leaving 1s. Some people might even make you do that in other schools. I don't have a vision for canceling and writing 1 like 642 times. So there's always 1s. If you need them, they're there. Just know they're there. Use them when you need them. But personally, I'm not writing 1 every time I cancel because I'd have run out of chalk by now. So, see you later, everybody.